Okay, so here's a question. You can see by the picture that it's a kind of quadratic question, but it doesn't actually, it's not actually obvious. It's obvious sometimes. Okay, so just reading this, so particle P is moving in a straight line on a fixed point. O is a fixed point on a straight line. The distance S meters, so S is the meters of P from O at time seconds is given by, T seconds is given by. So S is the straight line, the meters, so therefore the higher here, the further away, if you like, that's why it's the distance. Use algebra to find the greatest distance of P from O. So the greatest distance from P to O. And so what we need to figure out is this top point here. Okay, so we call that when it's on an upside down curve like this, it's the maximum point. Okay, and to do that we need to complete the square. Okay, so that's actually what you're trying to find when you complete the square, is the turning point of a quadratic. Now this one's challenging because if you look at the squared portion of this, it's -5 as the coefficient, so it's actually has a little bit more going on. So what we need to do before we can actually do the completing the square part of it, we need to take out that -5. And if we do that, sorry, there's a square bracket there. And if we do that, we'll end up with t squared. It's -5t squared divided by -5 is just t squared. And then minus, because obviously you're dividing by minus, so this 80 actually becomes, instead of being positive, it will become negative. So you need to kind of be careful of that. And so that would be -16t. Okay, so there's no constant term now, it's just t squared and t. So we've got it in that format. We need to now complete the square on this middle section here. So we keep that -5 out. And then if we complete the square inside, we'll end up with t. You half this 16 to get -8 squared. And then you will take away the square of 8, which is 64. And then we'll close the all square bracket, because this part inside here is this bit here. We still have this -5 that's been kind of factorized out. Our next step is to multiply this -5 by anything that's outside. Now we've got -64 out here. So this is when we get rid of the square bracket, and we end up with t -8 squared, and then -5 times -64, that would be plus 320. And that is now in the completed square format. Now that gives us the coordinate of where this graph turns. Now the x value is the opposite of this, so it would be 8. And the y value is just this 320 here. We can ignore the -5. So it's 320. And it should be both positive. Again, they were using a real life kind of situation here. And it's in this first quadrant, so it should all be positive, and it is. So 8 along, time-wise, after 8 seconds, the distance is 320 meters, and it's this point kind of at the top here. So that's kind of like a bit more of a real life kind of one. They've made it slightly harder with that -5, but then they've slightly eased it a little bit because there's no constant to worry about too much. But it's just a case of then finding what that's going to be. So that's 320, and that is our answer. Okay, so I hope that was quite straightforward. For feel free to make a comment or anything if you feel like you're still not sure about that. But hopefully, if you've done some completed square format before, then it should be relatively straightforward. Okay, thanks for listening.